In 430 years before Christ, a philosopher named Democritus dared to imagine a world invisible to the eye. He whispered to the winds of Athens, "Everything is made of tiny, indivisible particles. No one could see them, yet he believed they existed. Not all were convinced." Aristotle, the great teacher of the world, declared that matter is continuous, unbroken. A debate that would echo for centuries began. For centuries, the idea of the atom lay dormant, buried beneath the weight of dogma. The building blocks of matter waited, patient as time itself. The ideas, the breakthroughs, the choices that shaped our world reveal how great minds thought, struggled, and built the future. Every lesson, every spark of brilliance is a minting of thought. And every invention, every battle, every vision leaves a trace. I'm Atlas, and I welcome you to a journey where history fuels your growth. This is Mind Mint. Before we begin, subscribe and hit the bell so you never miss a story. And when we're done, leave a like if this chapter sparked your curiosity. Now, let's uncover the details behind today's story. The Renaissance rekindled curiosity. Observers like Leonardo began measuring, observing, and questioning nature. Every leaf, every ripple, every shadow became a clue. The scientific revolution opened a door. Cavendish's experiments with hydrogen suggested that elements might themselves be composed of smaller units. The atom's shadow returned to human thought. In 1803, Dalton formalized the atomic theory. He proposed that atoms are discrete, indivisible, each unique. For the first time, humanity had a framework to understand matter itself. Dalton's ideas spread like wildfire. Laboratories became arenas of experimentation, where curiosity shaped a new understanding of the universe. Though invisible, atoms were real, waiting to be glimpsed. The secrets of matter lay beyond sight, hinting at forces unimaginable. Little did humanity know, the atom would soon reveal a world stranger than fiction, one capable of reshaping reality itself. The journey had begun. Soon, we would peer inside the atom and discover a universe within the universe, where reality itself dances on the edge of imagination. In Paris, J.J. Thomson observed tiny particles racing through cathode tubes. These electrons, invisible yet real, were among the first glimpses of the atom's inner life. Thomson imagined a plum pudding atom, a tiny universe of scattered charges. It was an imperfect model, but it hinted at an inner structure, a hidden world within the atom. Rutherford's experiment revealed a shocking truth. The atom is mostly empty space, with a dense nucleus at its heart, like a hidden sun in a vast void. Bohr envisioned electrons as dancers, jumping between energy levels, absorbing and releasing light. The atom became a cosmic symphony of motion and energy. Then came quantum mechanics. Schrödinger and others revealed a world of probability, where certainty vanished and particles behaved like both waves and matter simultaneously. Heisenberg declared that one could never know both position and momentum of a particle perfectly. The atomic world was no longer predictable, it was mysterious, strange, and beautiful. Atoms, once thought simple and solid, now appeared as vibrant, dynamic universes, revealing complexity beyond imagination. Hidden within these tiny particles was a power humanity was only beginning to comprehend, a force that could illuminate cities or destroy them. The atom, playful and enigmatic, challenges everything we thought we knew. The rules of the universe are not as they seem. Soon, humanity would unlock the nucleus itself, and the smallest particles would speak in a language of unimaginable power. By 1920, scientists were peering deeper than ever before. Ernest Rutherford, already famed for revealing the nucleus, began probing its secrets with daring experiments. Rutherford fired alpha particles at atoms and observed astonishing deflections. The atom was no simple sphere, it contained a dense, charged core. The seeds of nuclear science had been planted. In 1932, James Chadwick discovered the neutron, completing the picture of the atomic nucleus. Now, scientists understood that atoms were more than empty space. They were structured worlds of protons and neutrons. It became clear that immense energy was trapped in these tiny cores. Splitting them could release power beyond imagination, a discovery that would soon alter the course of history. Throughout the 1930s, the race to understand the nucleus intensified. Researchers sensed a revolution approaching, unaware of the ethical storms ahead. The political clouds of the late 1930s loomed large. Knowledge, powerful and dangerous, was being uncovered in a world teetering on the brink of war. In 1938, Otto Hahn and Fritz Strassmann achieved nuclear fission. The atom's inner fire had been unleashed, promising both energy and devastation. The world stood at the edge of a precipice. Humanity now held a key capable of creation and destruction alike. The atom had become both a wonder and a threat. Electrons, once invisible, now revealed their dance around atomic nuclei. Quantum mechanics suggested they were not particles in fixed paths, but clouds of probability. Schrödinger's cat illustrated the strangeness. Reality at the atomic level defies intuition. Particles exist in states of possibility, collapsing into certainty only when observed. Heisenberg declared that the more precisely we measure one property, the less we know about another. Uncertainty is built into the very fabric of matter. Quantum principles, once theoretical, began powering technology, from electronics to imaging, bridging the atomic world with human innovation. By mid-20th century, quantum mechanics had transformed our understanding. The atom was no longer a static particle, but a dynamic realm of endless possibilities. Yet, with knowledge came responsibility. The same principles enabling innovation could be turned into instruments of destruction. The invisible dance of electrons hinted at forces that could change the world forever. Atoms are both the architects of life and the harbingers of power. Soon, humanity would confront the consequences of controlling these tiny, potent worlds. As the world edged into war, the promise of atomic energy became a secret of urgent consequence. Scientists faced a moral crossroads: knowledge for peace or knowledge for power. In 1942, the United States launched the Manhattan Project. Brilliant minds like Oppenheimer and Fermi converged to turn theory into an unparalleled weapon. Under the pressure of war, experiments accelerated. The potential of the atom became terrifyingly tangible, each day bringing them closer to a force capable of annihilation. Some scientists questioned their role. Could humanity wield such power responsibly, or had curiosity led them into a moral abyss? Enrico Fermi achieved the first controlled chain reaction, marking the moment when human hands could truly harness atomic energy. The atom's hidden fire erupted over Hiroshima and Nagasaki. The world glimpsed both the ultimate power and ultimate vulnerability embedded within each atom. Humanity had unlocked a force of creation and destruction. The atom's story had entered a new, irrevocable chapter. And yet, this was only the beginning. The atom would continue to shape our world in ways we were only beginning to imagine. Beyond power and destruction, atoms are the building blocks of life. Every leaf, every drop of water, every breath we take is composed of these tiny, invisible architects. Carbon, oxygen, hydrogen, and nitrogen combine in intricate dances, forming the molecules that sustain life itself. The structure of DNA, unveiled in 1953 by Watson and Crick, revealed an atomic choreography that encodes life. Atoms also heal. Radioisotopes detect disease. Radiation treats illness, proving the same particles that once destroyed can also save. Atoms drive the processes that feed us, hydrate us, and sustain ecosystems. The invisible world underpins everything we see and touch. From the air we breathe to the stars above, every human is a vessel for atoms that have journeyed across time and space. The same atoms in our bodies were forged in the hearts of stars. In them, we carry the story of the universe itself. And yet, the deeper we look, the more mysteries emerge. The atom has secrets that remain untold, waiting to reshape reality once more. In the 21st century, our exploration of atoms continues with unprecedented precision. We split, accelerate, and manipulate them to probe the very fabric of reality. Machines like the Large Hadron Collider allow us to recreate the universe's first moments, revealing the particles and forces that shaped existence. Fusion energy promises a future powered by the atom without destruction. Scientists chase a dream of endless clean energy. Quantum computing harnesses the strange behavior of subatomic particles, opening possibilities beyond classical imagination. But with power comes responsibility. Each atomic breakthrough challenges ethics, safety, and the meaning of control. Atoms and molecules allow us to treat disease at the smallest scales, repairing bodies from within. Atoms continue their journey through the cosmos, forming stars, planets, and potentially new life across the universe. Every discovery leads to another question. The atom, tiny yet infinite, holds the keys to worlds we have yet to imagine. From ancient philosophers to modern physicists, humanity has always sought to understand the building blocks of existence. The atom has inspired imagination, art, and philosophy, shaping culture alongside science. Atoms persist beyond generations, indifferent to human triumphs and failures. They are eternal witnesses to the story of life. The same particles that dance in our bodies dance in distant stars. We are connected to the cosmos at the most fundamental level. Atoms hold both creation and destruction. Our challenge is to understand them, not to be ruled by them. The quest for knowledge continues as each generation unlocks secrets hidden within the smallest corners of reality. Atoms are the storytellers of existence, tracing a narrative that began billions of years ago and will continue far beyond us. In every atom, there is a story of creation, life, and endless potential, and in understanding them, we understand ourselves. The atom's journey is our journey, infinite and ever unfolding, reminding us that the smallest things can hold the greatest mysteries. And so, dear listener, that's where today's story ends. Let's continue walking the path of great minds and moments together. Remember, every great mind was once just curious. Stay curious, and I'll see you in the next chapter of Mind Mint. Goodbye.